Good morning, student. Again, we are continuing the same topic that how we can run the message authentication over IoT. In the previous video, we have seen what are the methods, what are the types, and what are the algorithm that we can use over IoT to protect the message. And now we can, in this video, now we can see that how we can implement that procedure over a new simulator as we called as cooja simulator. It is a new simulator as well as the emulator that we are working on it. So now this video is totally depend on the simulation part. So here I have been implemented on the new tool. Maybe you all know that the IoT tool, which is also known as the cooja. It is a quantity operating system with a framework of cooja simulator. Here we have to run the quantity operating system on the VMware, where in the VMware they are the framework known as cooja. Cooja is basically based on the JVI, Java Virtual Interface. It is a lightweight and the backend programming is being done on the C language. So you can see that this is the initial screen of cooja while I've been started initialize the cooja. So after that I have been added the modes means you can also known as the node or the sensors. I have chosen the sky mode. Sky mode is the simplest mode for performing the simulation because sky mode is easy to handle and the parameters are very easy and it gives the efficient result. Here you can see I have communicated the two sensors in a unicast system. They are the borders. You can see they are the green border and the gray border. In the green border they are communicating between 1 to 2 and the 1 is the 100% in the range of 2. So it is a unicast system. If the range of 1 is outside the 2, it cannot communicate. So for that we have to make one another sensor for communicating via third sensor. So that is another thing, but this is a unicast communication, so I have to do multicast communication in future. But while communicating unicast, we have first implemented the terminal connection where you can connect from one sensor to another sensor via internet, over internet. We have created a unicast communication from client to another server, and the bridge has been established via connection terminal window. After that the connection has been established, you can see that the client connected with this IP address and the sockets are modes. The sensor has been sent some bytes from one sensor to another sensor. And on the other side you can see the mode sends to socket, means some byte has been sent from sensor to another sensor. So in this I have been used the less algorithm in the unicast system. So while I have been used one node and the encryption time is 1007 while the decryption time is 1125. So while that I've been increased the file size. Maybe you can see that 10, 20, 30, 40. This is the bytes and I'm increasing the bytes and I'm seeing the encryption and decryption time of the file size. You can see that. So my conclusion is that I've been implemented the unicast communication on the new environment known as the cooja quantity operating system with using COAP protocol under the DTLS security. While COAP is comfortable to communicate in the multicast system, but DTLS is not comfortable or not able to communicate or provide security to the multicast system. So in future I can use some more algorithm for more double channel system for communicating from one sensor to another sensor and the various sensor one to many. So in the future I can maybe use the more algorithm or implement more algorithm for securing the multicast system through cryptography algorithm. So that is more reliable in some of the areas or the smart objects. So this can be implemented on Contiki also. So thank you very much, sir. Thank you, sir.